Hello everyone, this is video 9.2. We're going to be looking at expressions with variables. So this is going to be building on the previous video 9.1, which was just dealing with expressions themselves. So we're going to be introducing the concepts of variables and how that impacts how we understand what expressions are. So let's get started. So we should define a variable, a letter or symbol which stands for any other number within a set of numbers. That's kind of the book definition. You've probably seen a variable before, so you know that typically it's a letter, and we're going to use it to hold some sort of value, and it's going to be typically what we're going to be solving for one specific value. Now, we need to know within which set of numbers, and that may seem like a silly point, but it's actually a pretty important one. So if we have something like x minus 5 or x plus 5 equals 2. So for some students, that's not going to be a solvable problem because they haven't seen negative numbers yet. So if we're only working within the set of numbers of positive numbers or the counting numbers, the whole numbers, how are we going to think about it? If we're only working within positive integers, then there's not a solution there. And the same thing is going to be true if we have something like x divided by 3 equals 2. For students who haven't seen fractions yet, that's not going to be a solvable problem. For students who have, it will. And this goes all the way up until we get to something like k squared equals negative 1, where students who have seen imaginary numbers will be able to solve that equation. And for students who haven't, they won't. So that set of numbers aspect is pretty important. And it may seem like a minor aspect of that definition, but it's actually pretty important. Once we put a variable into an expression, then it becomes a variable expression. So this is a weird point, but once we've introduced the idea of a variable expression, theoretically something like 5 times 2 could be a variable expression, even though it doesn't contain a variable, by the merit that it could contain a variable. So in the same way that 3 is a rational number, because we could write it as a fraction, even though we don't typically write it as a fraction, the same thing could be true for a variable expression that, if it could contain a variable. But for our purposes, we'll say that if it does contain a variable, then we'll call it a variable expression. But we could be flexible with that, but we won't. I want to add one little piece to this, and this is about this idea of from Zoltan Dienes, who was a mathematician and a math education researcher, and he had this idea of what he called the variability principle. And what the variability principle says is that students, when learning mathematics, should see things in as many different forms as often as possible. And the reason I'm bringing this up is because we have students who, because they see x as the variable so often, if they have a problem like 3x plus 1 equals 7, they can solve that. But if they have 3r plus 1 equals 7, they start to panic. And so what that tells us is that those students have seen x as the variable so often that they've become comfortable with it, but they haven't seen something like r as a variable. So even though it's the same thing, I mean, mechanically, it's the same idea. And there's not a whole lot of difference between saying x equals 2 and r equals 2. But if students aren't introduced to other letters besides x as, or y as variables, then that poses something of a problem. So just be thinking about that when you're writing problems, when you're doing problems, when you're introducing ideas to class. If it's a lot of the same thing, that's probably not helping students develop broad ideas around whatever concept it is that you're teaching. All right, in this case, variable. This is also probably a good time to start using the dot instead of the x for multiplication. So if we have 2 plus 3 times x, you can see the problem with that. So using the x for multiplication as well as the x as a variable, this poses something of a problem. So, typically I would say using an x for multiplication is okay until you get to variable. You may want to start anticipating that. Introducing a new symbol for multiplication and introducing variable at the same time uh, might be a lot for students to swallow. So you may want to think about a section or two or a chapter or two ahead of this to introduce that dot for multiplication. So we want to move from that to 2 plus 3 times x, or even 2 plus 3x, writing multiplication, one of those two ways. So introduce some new form of multiplication, getting away from that x. Okay, so let's look at a problem where we're going to be evaluating a variable expression for two values. We're going to be evaluating 100 minus 16 times the quantity t squared minus 4t plus 4. And we're going to evaluate it once at t equals 4 and once at t equals negative 4. That's a terrible line. Let me try that again. That's a little better. So we'll do t equals 4 over here, and we'll do t equals negative 4 over here. So we're going to do this by substitution. So we're going to put a 4 in for t. So we get 100 minus 16, and this is going to be 4 squared minus 4 times 4 plus 4. So after we do the substitution, we just need to follow order of operations. And I just want to point out, we're going to do parentheses first. So we're going to do the parts that sort of in the parentheses. But then after we've simplified this within solving the parentheses, we should follow order of operations within doing that. So within here, we should do the exponents first. So we've got 100 minus 16. Now the exponent is going to be 4 squared, makes a 16. And minus 4 times 4 plus 4. And now we can do multiplication from left to right. And now we do our addition and subtraction. We see these cancel. This is a 4. So this is 100 minus 64 equals 36. And I'm missing some equal signs along here. All right. So we have our order of operations, but we want to notice that we're doing this addition and subtraction before we do this multiplication, because the addition and subtraction is part of the parentheses. Now, if we want, we could do that multiplication first by doing the distributive property. It's going to make my numbers get a little bit bigger. I got to deal with the 256 a couple times, and it gets a little bit messier. So it's not that we can't do it. It's just probably not the way that I would do it. But there's I guess merit for doing it that way as well. If we look at t equals negative 4 on the right hand side here, so the same thing, we're going to do our substitution. So we're going to get 100 minus 16 times negative 4 squared minus 4 times negative 4 plus 4. Now, I've written this a particular way here. I've written it actually kind of incorrectly because I want to talk about students doing this. So if a student writes this as negative 4 squared, then they're going to get negative 16. So if you write it this way, then they're going to do the exponent first and then do the multiplication with that negative second, and that gives them negative 16, which is correct for how they've written it. Also, if they punch into a calculator this way, the calculator is going to bear them out and going to show that it's negative 16 also. So the error is not necessarily in the math that they're doing, but in the way that it's written. We have to remind students, and maybe even ourselves, that when we do this substitution, they were substituting in a single value or a single quantity. So when that negative 4 goes into that t, it should go in as a parenthetical expression. It should be in parentheses to show that it's a single value. And so now when I do the -4 squared, I should recognize that this is -4 times -4. And so that gives me a positive 16. So whether or not you include that negative or not, or whether or not you include this parentheses or not, is going to make a difference in whether or not you include that negative in the square or not, which is going to make the difference between whether or not your answer is positive 16 or negative 16, which throws this answer off completely. Um, so it's a huge difference between the two. So in doing these evaluations, not only do you have the variable expression evaluation aspect of these problems, but you have a lot of other things working as well, like order of operations. So it's a lot to keep track of what's happening in student work in doing these problems. So we finish this out. This is 100 minus 16. So we know now that this is a positive 16, this is a positive 16, and this is a 4. So if we add this together, 16 and 16 is 32, makes 36. So if we multiply this together, we get 16 times 36 is 576. So this is 100 minus 576. So we get negative 476. A pretty significant difference from positive 36, which is what we would get if we were to leave out these parentheses. If we leave out these parentheses, then we get a negative 16. This all cancels, and it looks just like t equals 4. So makes a huge difference. There's a lot to watch out for. The further along we get into algebra, the more moving parts we have. Students have to have a lot of things in mind in solving these, so there's a lot of things to look out for, a lot of pitfalls, a lot of areas where students can make mistakes. So if you're a checkpoint, this problem should look kind of familiar. It's the same figure from the 9.1. So you have the same L-shaped polygon. What I would like for you to do is express the area of this using at least two different numerical expressions, but now instead of having things that are numerical, you have things that are algebraic. Now, if you have your answer, if you did the first problem and you have your answer from that, you can use that to sort of start to figure out how to approach this. The method of breaking up the shape into rectangles shouldn't change, but how you express the area, how you're going to express the area of the individual rectangles and the sum itself might be a little bit differently. I'll leave it up to you how much you want to simplify what you have. I would recommend, for at least a little bit of practice, you try to simplify it at least a little bit. But I will leave this problem with you. If you have any questions about this problem, as always, please let me know and we'll get them answered. All right, thank you.